Welcome everyone. My name is Satish Lodam and today I am going to explain you how to configure a DNS server on Linux system in a jail using a chroot facility for our 11G release 2 grid infrastructure setup. Before we move on to the actual configurations, for those who don't know about DNS, they might typically ask themselves what is a DNS and what do we need it for. So a DNS, which is an acronym for domain name system, helps you remember an otherwise a difficult identity of a network computer, which is the IP address of that computer. So as you know, each computer on internet has its own logical unique ID, which is the IP address of that computer. Remembering all the computers using their respective IP addresses is just impossible. DNS helps you name them, and then you can use the user-friendly name instead of the IP address to reach a particular host on the network. In the Linux world, a DNS server is implemented using the bind software. Bind is an acronym for Berkeley Internet Name Domain Project. Now DNS can be implemented using purely a Linux system in an unsecured way, or within a Linux system you can further go for security hardening using the chroot facility. To secure the DNS, we normally choose to run it using a chroot facility. The chroot facility works as a secured container, also known as a jail, for a given software. So if someone, typically a hacker, compromises the security, he cannot access any other file running under the normal root file system in Linux. The only files he can access are the ones available in the container. And since we have created the chroot container for DNS purpose only in the implementation, in our case all those files are purely related to DNS configuration. So even if somebody compromises the security, he cannot tamper any other file on the system except for the files related to the DNS configuration, and surely you would be maintaining a good handy backup just in case if you need to restore. Thus a chroot facility gives you a secured environment to run a given sensitive software. In 11G release 2 grid infrastructure implementation, you would more than once need a DNS setup. There are primarily two components within your 11G release 2 Oracle grid infrastructure, such as SCAN, which stands for single client access name, and GNS, which is a grid name service or a system. Both these services in 11G R2 grid infrastructure would require a DNS to be configured in your environment. SCAN is a DNS published set of 3 IPs which resolve in a round-robin manner when a client puts a query to the DNS server asking for the SCAN IP using the SCAN name. SCAN allows you to change the background setup, that is the number of servers in your cluster can change without you changing the client-side setup in the client-side tnsnames.ora file. So this gives you a transparent server-side implementation without reconfiguring any of the client-side files. The second feature of 11G R2 Oracle grid infrastructure is the grid name service or the system, which allows you to use a DHCP facility to obtain dynamic IP addresses for the clustered nodes. So you no longer need to assign static IP addresses which you need to assign until 10G release 2. So 11G can obtain those IP addresses using a DHCP facility. For this, it's required that a GNS VIP should be associated with a subdomain delegation within the DNS. So what is this subdomain delegation? What are those configuration files? Everything and other relevant configuration related topics I'm going to discuss once we are on to actually the DNS configuration part of it. But before we venture into directly editing those files on a Linux box, let's first understand the kind of 11G release 2 grid infrastructure setup that we are planning to do. So during the planning phase, this is what I have prepared. So I am going to implement a 3-node cluster, which is 11G release 2 grid infrastructure, and the cluster configuration as shown in this Excel sheet. So I am going to name my cluster as my cluster itself, and it's going to have 3-node configuration. The node names derived here are from the name of the missiles which ISRO developed here using the indigenous technologies. So Prithvi, Trishul and Akash, I assume, are the 3 nodes that I plan to implement in my 3-node cluster configuration. Here are their public virtual IP, private NIC for each of these nodes. So each node has 3 NICs in all. NIC is the network interface card. ETH0 is going to be my public interface, while ETH1 and ETH2 I am planning to configure as a redundant interconnect within my cluster. We have almost similar configuration setup across all 3 nodes, meaning ETH0 on node 1 Prithvi, node 2 Trishul and node 3 Akash is all a public interface. ETH1 and ETH2 are namely the private interfaces onto node 1, node 2 and node 3. You don't actually need 2 private NICs, one is sufficient, but since going further I want to explore the 11G release 2 grid infrastructure new feature called as HAIP, which is a configuration of a redundant interconnect using more than one NICs purely at an Oracle level, bypassing any of the OS facilities which we commonly used in 10G, such as NIC bonding, Ether channel, IPMP or trunking. So instead of configuring these facilities of NIC bonding, NIC teaming, IPMP or trunking, we'll configure 2 independent private NICs purely using the Oracle's own new service called as the highly available IPs, and this can only be used to configure redundancy for private interconnects. HAIP cannot be used to configure redundancy for public interfaces. So if you are still looking for redundancy for public interfaces, you should still use the OS native facility using bonding, trunking, IPMP or whatever that OS offers. So node 1 in my case, Prithvi, the public IP address of that node would be 172.168.40.2. I ensured that none of these IP addresses are being used elsewhere in my network. The virtual IP that I plan to assign to Prithvi is 172.168.40.3. The first private IP assigned to Prithvi would be 192.168.198.2, and the second private NIC for my node 1 Prithvi would be 192.168.198.3. Similar way, I have defined those IP addresses public, virtual IP, private IP address 1 and private IP addresses 2 respectively for my second node Trishul and for my third node Akash, and they have been associated with their respective NICs. Ensure that your private network is a non-routable network, while a public network should be a routable one. So a public network should have an assigned gateway, which means it's a routable, and a private network on which I am currently using a gigabit Ethernet to privately connect all the clustered nodes. They are all non-routable. So this way I ensured that IP addresses assigned are from two different subnets. The public IP assigned to all the nodes belongs to both public and virtual IP belongs to the same subnet, which is a class B network in my case, and the network to which these IPs belong are from 172.168 network. On the similar lines, I have defined the IP addresses required for my private NICs, two of them on each node, and they are class C IP addresses here and belong to the network 192.168.198. Those respective IPs have been assigned to the designated network interface cards. Now, apart from the clustered nodes, I am going to have additional requirements to set up a DNS server. I have here chosen a name DNS1 for my DNS server, and the IP address that I plan to assign to this particular server is 172.168.40.100, which is unique within my network, and it's also on the same subnet as that of my public and virtual IP addresses of my clustered nodes. Also, I have a storage, which in my case is a NetApp filer. The NetApp filer is also set up using an IP address 172.168.40.200. Now, using this IP address, I would be able to log into my NetApp filer to do the command line configuration of aggregates, volumes, and LUNs required for my shared storage for my 11G release 2 cluster configuration. As we discussed during the DNS, 11G can only be set up using scan facility. So as I mentioned here, a scan, which is an acronym for single client access name, is a set of 3 IP addresses which you need to publish within a DNS, and they would resolve using a round robin manner. Whenever a client puts in a scan name, my DNS would resolve them to one of the 3 IPs in a round robin manner. So clients would randomly get routed to one of the 3 scan IPs that I put in my DNS. I have selected those IPs to be 172.168.40.10.20.30. They are also on the same subnet as that of my public and virtual IP addresses of my clustered nodes. Now, to go further and configure a DNS system, in my case I am going to use RedHat Enterprise Linux 5.4 for my DNS setup, and this is already the machine that I have configured. It's purely a bare metal installation, bare minimum installation on a machine which purely has RedHat Enterprise Linux 5.4 64-bit edition of Red Hat Linux, and the IP address that I assigned to that machine is 172.168.40.100. Here onwards I am going to save this name as in my putty configuration. So every time I want to log in, I don't have to type in the IP address. I can select from the drop down list the name of my DNS server. So once I log in to that particular server, I hope it's routable and it's up and running as of now. Once I log into this particular host, I log in directly with the root authority. I would then check the bare minimum setup that needs to be there in the place. So I am checking. Here's my server that I am onto. I am using Red Hat Enterprise Linux 5.4. The kernel version is 2.6.18-164 Enterprise Linux 5, which is a symmetric multiprocessing machine, and it's a 64-bit edition of Red Hat Enterprise Linux. So here I am. So my machine's name is dns1.oracleexpert.com. This is the one that I plan to configure as a DNS server for my setup. And here's the only NIC attached to this machine, and the IP address said, which I mentioned earlier, 172.168.40.100. So to ensure whether I have the necessary softwares installed on this machine, I am going to make a sanity check about my installation. So bare minimum, I need the bind software to configure the DNS server, and as I said, I am going to go for a secured implementation using bind or a DNS server running under a virtual chroot container, which is also known as jail. So here I can see bind version 9.3.6-4 is already installed on my computer. Next thing is, I am going to ensure the status of my DNS server as of now. The DNS service name is named, and I can see from here as of now the service is not running at all. So to start configuring the setup about the DNS, I need to start editing a couple of files under suitable directories. Now since I am using the chroot facility, all my configuration files are kept under chroot directory as such. So here you can see that I have dev, etc and var directories by default. I go into the etc configuration and then I start editing a file called as named.conf. Now DNS, this is the global configuration file for your DNS server. So it starts with defining a couple of options which controls the behavior of your DNS server. So I am going to start with configuring the generic options required for my DNS setups, including options which tells me where should be my configuration directory be kept. So the parameter itself is directory followed by the complete path to that directory. Now where should my DNS server listen for name to IP translation queries? So I am saying that listen port is 53 and my machine should listen on all the IPs assigned to it. So there would be two IPs. One, as I mentioned earlier, is the IP address of my DNS server 172.168.40.100, and the other would be the local IP address, which is 127.0.0.1. I want my DNS server to listen on all the IPs. That's why I mentioned listen on port 53 on all the IP addresses. Now each section is included within curly braces and ends with a curly brace with a semicolon. Now once I have defined the basic settings, I need to define the zone itself. So I am starting defining my zone, which in my case is oracleexpert.com, and then specific to this particular zone, I need to identify what type of a zone is this. In my case, it's a master zone. Then the file which would contain the configuration of my zone. I am choosing the name as forward lookup zone file, and the end of the configuration for this zone. So this means I am going to configure a DNS for a domain called as oracleexpert.com. This is going to be a master domain, and the file which will contain all the details about this zone would be oracleexpert.com.fwd.zone. Remember that a DNS server has two different zones. We call them as a forward lookup zones, which translates a name to an IP address, and a reverse lookup zone which is used to translate an IP address to some name. So they do basically a reverse of the job, name to IP and IP to name configuration, namely using forward lookup zone and a reverse lookup zone. You can think them as if they are two separate databases where name to IP or IP to name mapping is stored. Now this is my forward lookup zone definition for oracleexpert.com. Similar way, I should have a forward lookup zone definition for a zone called as localhost, that is using 127.0.0.1. So I am going to type in pretty much a similar section for this one as well, using some configuration file, let's say localhost.fwd.zone. That FWD name I deliberately selected to indicate the purpose. And as I said, each configuration section must end with a curly brace and with a semicolon. Apart from forward lookup zone, you would also need a reverse lookup zone. A reverse lookup zone typically includes a IP address in a reverse style. So my IP addresses, in this case public IP addresses, are in the form 172.168.40.x. if you see 40.2, 40.3, 40.4, 40.10, 20, 30, 100, 200 and so on. So a reverse lookup zone mentions those IP addresses in a reverse way, and then we define it with an internet style, that IN stands for internet addresses, and ARPA. So I am going to define a reverse lookup zone for our domain called as oracleexpert.com. So I am going to use the reverse of it, the one that I said here. So 40.168.172.in hyphen address, in is for internet type of an addresses on ARPA, and then again I am going to mention in the parameters related to this reverse lookup zone for my domain called as oracleexpert.com, and then I am going to mention in the name to be used by this particular file. So I am using .40.reverse as .some zone name. The section should end with a semicolon. Similar way, I need to define a reverse lookup zone which has always the IP addresses of the style 127.0.0.1. Again I would mention it in pretty much the same format, and then the reverse lookup zone specific setting, again I am saying that it's going to be my master reverse lookup zone and the file in which the configurations would be kept. So this brings me to the end of configuration of my master file. It starts with defining generic options for my DNS server. It then defines all the zones within your DNS setup. The domain I have configured is the oracleexpert.com domain. This is the same domain where all my cluster nodes would reside, and then there's a reverse lookup definition for the same zone, and then one default zone that is for my local host, and then the reverse definition for my localhost.local domain configuration. So once I am done, I have configured successfully named.conf. Now the next thing is, whatever names I have used for these files, I'm going to make a note of it, and then accordingly I'm going to configure these files. So here in my local notepad, I'm just going to keep a track of what names I have used, so that I don't accidentally end up typing something else, where the DNS server during startup would then error out saying I am unable to locate a particular file. So I made a note of all those config files that I need to configure, and then I move into, currently I am under chroot etc configuration. Now I need to move under var named, where these files are expected. This is the name that you gave. This should be where your files should be located. Now I am going to configure my first file. It's going to be fairly a long running configuration, and it could be even complex than what I am trying to show here. That depends on how many machines are there in the cluster, and are you going to eat up all those machines by mentioning all their details all in one go, or you are going to periodically revise that configuration. So once I am under var named chroot var named, I am going to use the file name that I mentioned in the global configuration for my forward lookup zone, for the zone named oracleexpert.com. Now it's going to be a free flowing file with a couple of DNS specific parameters, which as and when I type, I'm going to make a note of them. A TTL period defines time to live. So time to live I mentioned in my case as 1 day. IN is for internet style addressing scheme. SOA stands for the start of authority in my zone or for my DNS server, followed by the fully qualified name of my DNS server. Remember to include a dot at the name of FQDN. This is how it expects those names to be when you mention a FQDN within the DNS configuration files. And once I am done, I am going to put the zone specific parameters as on this date. I am going to use some serial number to identify my configuration. So going further, if I change, I can always assign a unique serial number which tells me when was this file last edited. So as of now, the date is 15th of July 2011. So this is for the first time that I am creating it. So I am going to mention 2011 July 15th, and this is for the first time. So the last two digits I am deliberately keeping as 00. This helps you track when this file was last edited. So next time when I edit, I am just going to edit today sometime. If I change this file, I am going to replace this 00 with 01, 02, 03 and so on and so forth. Next one is how frequently, so that serial number identifies just a unique setting. Any number is good enough. I use the year, the month and the date followed by a two-digit number. Then how frequently should be my refresh interval. I said 8 hours is my refresh interval. How frequently my caching DNS should retry a failed operation. What is the expiry period? And the minimum configuration required to be refreshed is after what interval. So all these parameters are described in the DNS configuration guide. That @ symbol here in the configuration is one of the DNS naming conventions, where that @ itself indicates or has some special meaning. It works as a this zone. So you can use it as a shortcut to represent this configuration. So whatever is this configuration, instead of saying that, you can mention it using the @ symbol. So going further, I am going to now add a couple of host entries here. So this is my internet naming style addresses. This is going to be my NS, which means the name server, and my name server is dns.oracleexpert.com. Remember, each host needs to end with some convention, and that is dot in our case. So A stands for an address entry. So the name associated with the address 127.0.0.1, the name is localhost.local domain. Remember, this is a free flowing file, so whatever juicy design you want to follow, you can follow that. It's a free flowing file. The fields must minimum be separated with a space. So here I mentioned that my local host is one name or a named address which is in an internet's format. A stands for an address and the IP associated with it is 127.0.0.1. Pretty much in the same way, I am going to configure the remaining hosts in my configuration. So I am going to add the names of all the machines pretty much in the same format, that is internet style naming, the address, and whatever is the IP address I am planning to use for my DNS server. Remember, for our DNS server we are using the IP address 100. Then there's another host called as netapp01. Again in the same format, the IP address for my netapp server is 200. Similar way, I am going to now add in the clustered node names. Along with their IP addresses. If I don't remember what IP addresses I have kept, that's why I kept this Excel sheet handy. So 172.168.40.2 is the IP address of my first node. Then I have the second node as Trishul. The IP address associated, public IP address of Trishul is 40.4. Then I have Akash, which is 40.6. Then I have the virtual IP addresses associated with each one of them with the name -VIP, which in my case is 3, 5, and 7. So this way I ensured that I have added all the machines in my cluster or all the machines within my domain oracleexpert.com in the forward lookup zone configuration file of my domain. Now after this, I need to mention if I plan to use GNS, I need to set a subdomain within my DNS, and this subdomain is delegated configuring dynamic IPs for my cluster. So this subdomain I am naming here with the record as $origin, the name as development aura grid.oracleexpert.com. So this is going to work in my setup as a subdomain delegation, and the name server associated with it would be cluster1-gns.dev oragrid.oracleexpert.com. So this is going to be the virtual IP or the name of that particular GNS virtual IP, which is going to be contacted when a cluster node needs an IP, and this would handle the subdomain delegation part within my cluster configuration, followed by the name of the DNS server within which this has to be configured. I forgot to mention a dot here. Similar way, I need to configure the name of the host itself. So remember, the name of the host which I want for the GNS VIP is cluster1-GNS. It's going to be of the type address, and I'm going to use one IP address that I haven't used before. This is also called as a glue record. So pretty much that's it. This ends the configuration for my forward lookup zone file. So we said the time to live, we mentioned the start of authority, which is the name of my DNS server itself. Then the caching DNS related settings, if you are using caching DNS. Normally we don't use caching DNS within an intranet. Caching DNS is more common on internet if you want to offload certain DNS queries to be going to the master node, master DNS server all the time. We normally implement a caching DNS, but just to make a provision for future use, I have added parameters related to caching DNS servers. They are not absolute mandate here. Followed by all the IP addresses and their respective names in the form of internet addressing scheme. So the class is internet class, and the way we have addressed them is A for addresses, followed by their IP addresses. So the only thing I see we didn't mention so far is the scan part. So I am going to use a scan name in our configuration, which is my cluster-scan. So I am going to associate now 3 IP addresses with it, pretty much using the same convention. Remember that those 3 IP addresses that I plan to use is 172.168.40.10, 40.20, and 40.30. So name is my cluster-scan, but there are 3 IP addresses which would resolve in a round robin manner. Once my client asks a question to this DNS saying, if the name is my cluster-scan, tell me what would be the IP. The first client would get the IP as 10, second enquiry would receive it as 20, third enquiry would receive as 30, fourth enquiry would again receive the IP address as 10, so on and so forth. This is purely for GNS. Once we go on to the cluster installation, that time we will see how to implement a GNS for the 11G Oracle 11G release 2 grid infrastructure services. So this way I have configured the forward lookup zone configuration file for my domain oracleexpert.com. Now I would be configuring the reverse lookup zone. So for my oracleexpert.com domain, I need to configure the necessary settings in a reverse lookup zone file, and this I have mentioned it into named.conf earlier. So I am going to edit a file here. I am going to put in the reverse lookup zone specific parameters here as well. Like always, the first record is the TTL record. So I said the TTL has to live for 1 day in an internet naming style. Start of authority is going to be my dns1.oracleexpert.com. Remember to put a dot always. Root.localhost, and the caching services, caching DNS related settings. Again, I am editing this file on July 2001. 15th July is the date, and this is for the first time that I am editing it. I give this name as serial. Similar way the other parameters. I want to keep this configuration to be refreshed every 8 hours. The retry for a caching DNS, if it errors out, should happen after 4 hours. 1 week for the expiry of the caching information. And 1 day is the minimum period. So this ends the configuration for the caching DNS server if you implement one in your network, followed by the regular entries. So name server entry in my case is dns1.oracleexpert.com. the last 3 digits of that IP address would be 100 for my DNS. So we need to mention, since we are talking about the reverse lookup zone, we need to mention the last digits of your IP address, the last octet. Again, and now these are all the pointer records. So the fully qualified domain name 200 is going to be my IP address for my storage, which is NetApp 01 in my case, with the fully qualified domain name. Similar way, 2, which is the name pointer record for prithvi.oracleexpert.com. Again a pointer record for the second node, pointer record for the third node, followed by pointer records for the virtual IPs that I plan to consume while installing the cluster configuration, which is prithvi-vip.oracleexpert.com. 5 is going to be the pointer record for the virtual IP used by my second node, and 7 would be the pointer record for my third node virtual IP. So this way all the necessary IP addresses, the public and the virtual IP addresses, the IP address associated with my DNS server, the IP address which is associated my storage, all have been mentioned with the last octet description within the reverse lookup configuration file for my domain. Once done, I am going to save this. Now similar way, I need to configure files for my forward lookup zone about localhost. In this configuration file, as we said earlier, this is for your localhost forward lookup zone configuration file. So pretty much the same settings I am going to mention, except for some of the differences. So I am going to copy over quickly this file and do the necessary changes. So I am configuring my domain forward lookup zone for the localhost forward lookup zone. Now I would edit it relevantly. So we don't need these many settings here. This is just going to be for the localhost configuration. So we don't need anything beyond this. Localhost only talks about one IP address, that is 127.0.0.1. So the first entry in my DNS here, which is in-ns, which is a name server, it's going to be for my local domain. @ remember is a shortcut. And then I said This is the intranet naming address 127.0.0.1. So fairly simple compared to the primary domain forward lookup zone file. Now I am going to copy my reverse lookup zone configuration file into my reverse lookup zone for the local host, and then I am going to make necessary changes for my reverse lookup zone. So pretty much the same thing that's required for the caching DNS, if at all you maintain one, followed by the in record internet style record name server, and name server in this case would be local host. You need to be very careful while typing this file because the conventions are pretty weird here. This is how the configuration files are to be maintained in case of DNS. None of these records are required, so I am going to get rid of all the other lines. Remember, 1 is nothing but the last octet for your IP address 127.0.0.1. So I created a pointer record in the reverse lookup zone file, and I mentioned the name server as localhost. So pretty much all the configuration files are there in place. We need to edit the DNS own name, DNS server's own names resolution method or the property file, which is on Linux system etc resolve.conf. So this may or may not help us. So we said search oracleexpert.com, and there's a subdomain. Remember, we designated as devoragreed.oracleexpert.com, and in the name server list you have, this is incorrect, 172.168.40.100. You might mention the name server as 127.0.0.1, which is also running here on the local host. Options related to names resolution: how many attempts, options related to timeout. So pretty much I am done with my name server description, resolve.conf. It's time to ensure that no firewall runs. Linux provides you IP tables as one of the operating system specific firewalls. So I am going to check and ensure that IP tables firewall has been disabled. If it is running, I would like to shut it down. So this statement ensures that next time after my machine reboot the firewall doesn't start, and then I ensure that currently it's not running by stopping the service. So we ensured. Now it's time to start the name server, the DNS system. So hopefully if all the configuration was foolproof, we didn't do any typo anywhere, then the service, DNS service, should come up quite nicely. So we have a DNS server now running on our machine. There was no configuration glitch as such, and now I can see the number of zones as 4, debug level and whatnot. So this suggests to me that the configuration files that we created have all gone fine. And now I can put a query using ns lookup. So if I say ns lookup Prithvi, so this says the query of names lookup went to, for the host Prithvi, went to a DNS server called as 172.168.40.100, and then the name it could find there was in the domain oracleexpert.com. The FQDN thus becomes prithvi.oracleexpert.com, and the IP address associated with that host is 172.168.40.2. Similar way, I am going to do a NS lookup on the scan IP. Remember, the scan IP name that we selected is my cluster scan. So I am going to put a query against it, and quite clearly my query went to a DNS server, which is the current host where I am running this DNS. The name associated with it is my cluster scan oracleexpert.com, and these were the IPs. Remember, 20, 30 and 10 are those three IPs associated with this name. So if I try to ping using this name, you should see every time there would be a different IP coming through. So this time it is, since it is not up and running on any of the machines, but you can clearly see this time it has tried the IP address which ends with .10. Next time when I tried, although the IP is not returning because this IP has not been yet assigned or consumed by any of the alive nodes in my cluster configuration, but second time when I ping, the request went to a different IP, and when I use it for the third time, it went to a different IP. So this proves that the round robin configuration is in place, and again it went back to 10, again it goes back to 30, again it goes back to 20. So this proves that DNS has configured my cluster scan.oracleexpert.com, which is my scan IP, and has associated it with three IP addresses .10, .20, .30 with the same name, my cluster scan.oracleexpert.com, and the name resolves using a round robin. Once it resolved to 10, next it resolved to 30, next it resolved to 20, next time it again resolved to 10, 30 and 20. So this proves that the necessary DNS configuration is in place. So this also brings us to the end of the discussion about how to configure a DNS server on a Linux machine in a jail, which is nothing but using the chroot facility for a more secure DNS implementation. And the configuration I had talked was very much limited to 11G release 2 grid infrastructure implementation. There could be more than other records as well. There could be a mail exchange record within your DNS, there could be NS records, and there are multiple other possibilities. You can put a text record in DNS, but then all these naming styles are not being used within your grid infrastructure configuration for Oracle 11G release 2. So I didn't talk about any of those DNS configuration setups. This is purely related to a DNS configuration which needs to be there in place for Oracle 11G release 2 grid infrastructure implementation. Thanks for joining in for this session. In the next sessions, we would see how to implement the DNS on the client side, how those clustered nodes should be set up so that they reach out to a particular DNS server, and when they ask the name, it returns them an IP address. Or the other way also is possible. If you see, if I give some IP, it should return me some name. So if I give some IP for NS lookup, doing the reverse lookup zone, using the reverse lookup zone file for my domain oracleexpert.com, it could find me out from the reverse config file that the IP address associated with Prithvi is the last digit as 2, and the name is prithvi.oracleexpert.com. So this is how my forward lookup zone and a reverse lookup zone in my DNS queries are helping me out. Forward lookup zone helps you resolve a name to an IP address, and a reverse lookup zone helps you resolve an IP address to some name. You could have also used a dig command if your platform supports one. So if you say dig and mention some scan IP, it gives you a bigger description as to how it has been configured within your DNS. Or let me try doing it with the full name. So I am sending a query using dig, and it says this is how in your DNS the name has been set up. So my cluster-scan.oracleexpert.com, this is the time to live that we mentioned, although we mentioned that time to live as in hours or weeks or days, it has translated into number of seconds. So dig also helps you obtain those configuration details from your DNS server, and my DNS server needs to be up and running all the time so that the nodes largely depend on name to IP or IP to name translation onto this DNS server. So thanks for joining me into this session where we discussed the DNS server configuration on a Linux system under the chroot container. In the next session when we configure, we will talk about how to set up the client nodes which runs a DNS client configuration. Basically, you just need to put a similar etc resolv.conf file on the clients, so that every time they struggle to get a name to IP or IP to name mapping, they would reach out to the DNS server for doing the necessary translation, and the DNS server in turn obliges by returning the name or the IP address depending on the query. Thanks for joining in. We'll see you in the DNS clients discussion.